Hello and welcome back to my channel. Here in this video we are going to discuss the last three questions, that is 4th, 5th and 6th from October November 2020 970952, that is probability and statistics 1. So here is the question number 4. In a certain country, the weather each day is classified as fine or rainy. The probability that a fine day is followed by a fine day is 0.75, fine and then again fine, and the probability that a rainy day is followed by a fine day is 0.4. Means first rainy day and then fine day, it is going to be 0.4. The probability that it is fine day on 1st April is 0.8. The tree diagram below shows the possibilities for the weather on 1 April and 2nd April. Complete the tree diagram to show the possibilities. So it is given that probability that on 1st April it is fine, it is 0.8. So it is rainy would be 0.2. Now the first thing, fine day followed by a fine day, the probability is 0.75, so it would be 0.75, and hence it would be rainy is the probability of rainy day is 0.25, and it is given that rainy days followed by fine day is 0.4, so the probability rainy day and then fine day is 0.4, so rainy days followed by rainy day is 0.6. so that's the tree diagram. I hope it was of some help. Let's do the next part. Here's the B part. Find the probability that 2nd April is fine. So 2nd April is fine, we'll find from this branch and from this branch. So the required probability is going to be fine day and then again fine day. So probability of fine and fine, or means add rainy day and then it is fine day. So on 2nd April it would be fine day in this way. So the probability becomes 0.8 into, we'll multiply the probability of the branches 0.75 plus 0.2 into 0.4, and we will get this value 0. This total value is 0.68. So the probability that on 2nd April it is fine, that is 0.68. I hope it is clear. Let's do the C part of this question. Let X be the event that 1st April is fine, Y be the event that 3rd April is rainy. Find the value of probability X intersection Y. So we will see the scenario where we can get the intersection, and we know for 3rd April we need to draw the cases. We'll get back to the tree diagram once again. So let's say it is 3rd April, then fine we can get from here fine and rainy, again from after rainy it is fine and rainy, then again from here fine and rainy, then from here again fine and rainy. It is given that probability that a fine day is followed by fine is 0.75, so fine and fine 0.75 here, and then again it would be 0.25. Rainy day after fine day is 0.4, so it is 0.4, hence it becomes 0.6. Similarly fine day by fine day 0.75, then 0.25, rainy day and fine day is 0.4, so it becomes 0.6. so X is the, here this X was fine day on event that fine day on 1st April, and Y is the event that 3rd April it is rainy. So we will find these two probabilities, and the probabilities would be 0.8 into 0.75 into 0.25, multiplication of the branches, and here it would be 0.8 into 0.25 into 0.6. I'll write it there. So this probability is 0.8 into 0.75 into 0.25 plus 0.8 into 0.25 into 0.6. So now we will calculate these two values. and 0.8 into 0.75 is 0.6, and 0.6 into 0.25 is 3 by 20, that is 0.15, so 0.15. Now 0.8 into 0.25 into 0.6 would be 0.12, so this total value become 0.27, and that's the probability. I hope it is clear. Let's do the next question. Here's the D part. Find the probability that 1st April is fine given that 3rd April is rainy. So it's like probability of 1st April is fine means X. It is given that there is a Y, because Y means 3rd April is rainy. So we'll find the probability of X intersection Y over probability of Y. And probability of X intersection Y we have already calculated from the previous part, 0.27 divided by probability of Y means it is rainy on 3rd April. So it would be like 1st April it is rainy, fine, then 2nd April it is again fine, then rainy. So we will calculate all the possibilities to get the probability of on 3rd April it is rainy. So the next one is fine, then 2nd April it is rainy, and then again it is rainy. Or the second one is if on the 1st April it is rainy and 2nd April it is fine and then again it is rainy. Similarly the last one, rainy and then again rainy, and all the 3 days it was rainy. So we'll calculate these probabilities, and we can take the help of tree diagram in first. Now we already have these two values from the previous part, and we need to calculate the last two parts. So these two will sum to 0.27. So the total value is 0.27 over 0.362, and which is going to be 0.27 divided by this value from the calculator, and we got it as 0.7458, so 7.746. so this is the probability that 1st April is fine given that 3rd April is rainy. I hope it is clear. Let's do the next question now. And here is the question number 5. The following table gives the weekly snowfall in centimeters for 11 weeks in 2018 at two ski resort, Dados and Linwa. So these are the values for it, like snowfall in centimeter. Represent the information in back-to-back stem and leaf diagram. So we will write Dados towards the left hand side and Linwa towards the right hand side. I'll draw the lines. We'll take the key as, we'll write key as let's say 1 5 1 5, and here it is, let's say 2. It means 12 centimeter Dados and 15 centimeter towards the Linwa. So here it is Dados and here it is Linwa, and we'll start from the minimum value. We can see it is 1 digit also, so like 0 here. So for Dados it is 6, so 06 and 08, and yeah, 1 digit is over. For Linwa it is 0, and the next value is 2, the next value is 9, again with 1. Now I write till all the values, like it is in 20s, it is in 30s, and it is in 40s, so till 4. So in 10s, 12, 15, 10, 10, 16, so 2 times 10, 0, 0, then 12, so 2, and then 15.5 and then 16.6, and here it is 15, 11, 15, 16, 10, 12. So it is going to be 0, 1, 2, 5, 6. With here in 20s in DDoS it is 28 and 22, so 2 and 8. In 30s it is in Linwa there is no number in 20s. In DDoS 30s 36 and 36 only, and here it is 32 and 36, so 2 and 6. In 40s it is 2, 42, and in Linwa it is 40, so 0. So that's the back-to-back stem and leaf diagram. Let's discuss the next part of this question. Here is the B part. Find the median and interquartile range for the weekly snowfall in DDoS. So I'll bring the stem and leaf diagram here. And here's the stem and leaf diagram for DDoS and Linwa both, but we'll only focus on the DDoS. Median is the mid value. So median here, since there are 2 to 4 to 6, 7, 8, 9, 10, 11, so it is going to be 11 plus 1 divided by 2th term, that is going to be 6th term, and 6th term from the beginning will start from here 1, 2, 3, 4, 5, 6, so it is going to be 15. And now in order to find the interquartile range, we require upper quartile and lower quartile for both. Upper quartile means the mid value of the upper half, means mid value of these two, this value, these values. So we'll start cancelling one from here, one from here, one from here, one from here, then we got the mid value as 0, that is lower quartile is 1, 0, and upper quartile means the mid value of the upper half, so one from here, one from here, and then one from here, and then one from here, so we got 8, so it is 28, and hence interquartile range would be upper quartile minus lower quartile. We could have written Q3 and Q1 also, and it is 28 minus 10 is 18. That's the interquartile range. Now the C part, the median, lower quartile and upper quartile of the weekly snowfall for Linwa are 12, 9 and 32 centimeter. Use this information and use the answer to part B to compare the central tendency and the spread of weekly snowfall in DDoS and Linwa. So for DDoS, median means Q2 is 15, Q1 that is lower quartile, that was 10, Q3 that is upper quartile was 28, and interquartile is not required here. We'll write IQR was 18, and for Linwa this Q2 median is given as 12, Q1 lower quartile is 9, and Q3 is upper quartile, that is 32, and hence IQR would be upper quartile minus lower quartile. 32 minus 9 is 23. So we will compare with the help of median and interquartile range. So we can say on average the snowfall in DDoS is more than the snowfall in Linwa. So on average snowfall in DDoS is more or higher, and the interquartile range for Linwa is more, so it means this mid 50% of the snowfall is more in Linwa. So we can say the amount of rainfall, snowfall is higher in Linwa, because it is 23 and it is 18 only. So that is the two things we always compare. First one is on average, that is median, and another is interquartile range, the spread of the data. I hope it is clear. Let's do the next question. And here is the question number 6. Mr. and Mrs. Ahmed with their 2 children and Mr. and Mrs. Baker with their 3 children are visiting an activity center together. They will divide into groups for some of the activities. In how many ways can 9 people be divided into a group of 6 and a group of 3? So since there are 9 people altogether, and if we divide them into 2 groups and one is containing 6, another has to be contain 3 members. So it does not matter you are making a group of 3 or making a group of 6, because the another group will be automatically formed. So we can say that it is going to be total in number of ways 9 people can be divided into group of 6 is 9c6, or we can say it is 9c3. Both are fine, and 9c6 is 9 factorial over 6 factorial, and 9 minus 6 3 factorial. So it would be 9 into 8 into 7 into 6 factorial divided by 6 factorial into 3 factorial is 6. These two got cancelled. 3 2s are 6, 3 3s are 9, 2 1s are 2, 2 4s are 8. So we got it as 12 into 7, 84. So there are 84 ways in which a group of 6 and a group of 3 can be formed. I hope it is clear, and let's discuss the second part. 5 of 9 people are selected at random from a particular activity. For a particular activity, find the probability that this group of 5 people contains all 3 of the Baker children. So let me scroll it up once. So for the 5 people, for the 5 selections, it is given that all the 3 children of Baker should be there. So it means there is only one way to choose them, because it's a 3c3, because there were 3 and we have 3 of all of them to choose. So it is like 3c3, and we are only left with 2 places. And for those 2 places, so first one, for these 3 places we can write 3c3 also, but it is going to be same. And then for these 2 people, for these 2 selections, we have 6 options. So out of 6 we are going to choose only any 2. So this is the favorable outcome, when we can, in the way we can choose the we can select the 5 people with this condition. And probability, since we are finding the probability, then we'll have to choose 5 people. This, the denominator would be the total selections, total number of ways we can select 5 people out of 9, and that is of course 9c5. So it is 3c3 is 3 factorial over 3 factorial minus 0 factorial, that is 1. So 3c3 is always of course 1, and 6 factorial, 6c2 is 6 factorial over 2 factorial 4 factorial. We could have directly calculated from calculator. It is of course fine, because we have calculator here. And then 5 factorial and 4 factorial. So we'll calculate this 4 factorial got cancelled, and 2 factorial, so I will write it 6 factorial here upon 2 factorial is 2, 5 factorial will go up, 5 factorial, and here it is 9 into 8 into 7 into 6 factorial. So these two got cancelled. We can write 5 factorial as 5 into 4 into 3 into 2 into 1, no need to write, 2 into 9 into 8 into 7. So 4 2s are 2 1 3 3 times. So we got it as 5 over 3 to just 6, 7 ja 42. So this is the probability, 5 over 42, or we can write in the decimal also, but that's fine. So that is the probability that the probability that group of 5 people contains all the 3 Baker children. I hope it is clear. Let's do the next question. Now all 9 people stand in a line. Find the different arrangements in which Mr. Ahmed is not standing next to Baker. So we have a fixed type of solution for this type of question. When 2 people are not going to stand next to each other, is like, first of all we'll find all the arrangements, and then we'll subtract the arrangements when both of them are together, both are next to each other. This is the best way to calculate this. So all arrangements, there are 9 people, 9 place standing in a line, so of course we can arrange them in 9 factorial ways, minus if both are standing next to each other, both are standing next to each other, it means we can take Mr. Ahmed and Baker as one person, one unit, and then Mrs. Ahmed and then his 2 children, Mrs. Baker, then 3 children. Now 1 2 3 4 5 6 7 and then 8. So we can arrange these 8 people in 8 factorial ways, and of course they can interchange their place. B can be here, Baker can be here, and Ahmed can be here, so it can be done in the 2 factorial ways. So these are the total arrangement, and now we will calculate what is 9 factorial, and this value is 3,62,880 minus 8, this is 80,640, and hence this value is going to be 2,82,240. These are the total different arrangements in which Mr. Ahmed is not going to stand next to Mr. Baker. Let's do the last part of this question, and here's the D part. Find the number of different arrangements in which there is exactly one person between Mr. Ahmed and Mr. Baker. So we can make a group of 3 people here, and one side, either of the side, Mr. Ahmed and Mr. Baker will come, and we have to arrange one person here out of course 9 minus 2 7. This first place, one place can be filled by 7 ways because there are 7 people, and afterward we'll see other 6 over here. Now we have 1 2 3 4 5 6 7 place to arrange in a single line, so it is going to be 7 factorial and multiplied by 2 factorial, that is 2, because they can also interchange their places. Ahmed can come here, come to the last, and Baker can come to the first one. So this is the total value. So 14 into 7 factorial. 7 factorial is 5040 into 14 is going to be 70,560 different arrangements. So these are the total different arrangements in which exactly one person will come in between Mr. Ahmed and Mr. Baker. So that's it for this video. This was the last question of this paper, but let's meet again in the next video with some other past year paper solution. Till then, thank you so much.